There's this one single chemical reaction that's happening literally all around us all the time. I'm talking about in your kitchen, on your car, even in a big roaring campfire. It's this kind of hidden force that's constantly changing the world we see. And to really get what it is, we've got to solve a little puzzle first. So, what is this powerful hidden reaction? Well, to figure it out, let's put on our detective hats for a second. Take a look at these everyday things. I mean, what could possibly connect a browning apple, a rusty old bike, and a campfire? Let's check out the clues. First up, we've got Exhibit A, the browning apple. You know the drill. You slice it open, and in just a few minutes, that perfectly white apple flesh starts to turn that kind of unappetizing brown. What is going on there? Let's file that away as our first clue. Okay, now for Exhibit B, a rusty bicycle. We've all seen it. That shiny metal frame gets left out in the rain, and before you know it, it's covered in that fleeky, reddish-brown stuff we call rust. It's another transformation. So, what's the connection? And for a last clue, something way more dramatic. A burning campfire. Wood just completely transforms into ash, and in the process, it releases all this heat and light. So okay, we have a slow browning, a gradual rusting, and a really fast burning. They seem totally different, right? But believe it or not, they are all connected by one invisible actor. And that culprit, the invisible element tying all of this together, is oxygen. All three of those changes, the apple, the rust, and the fire, are all caused by a chemical reaction with a very gas that's all around us in the air. This special type of reaction has a name, oxidation. And the main idea is actually really simple. In chemistry, whenever a substance combines with or gains oxygen, we just say it's been oxidized. That's it. That's the fundamental principle. So let's connect all the dots. Rusting, that's just iron combining with oxygen. Burning fuel, that's the fuel combining with oxygen, just really, really fast. And that browning apple, you guessed it, the enzymes in the apple's flesh are reacting with oxygen in the air. This happens all the time, even with super reactive metals like a fresh-cut piece of sodium. Now, you might be thinking, okay, so it's just a color change, right? But what if I told you we can actually prove that something is physically being added to the substance? That a rusty bike is, believe it or not, heavier than a shiny new one. Let's picture a classic experiment. Imagine you take some of that fluffy iron wool and you put it on a perfectly balanced scale. Then you heat it up with a flame so it starts to burn and glow. When it cools down, you'd see something really strange. The scale has tipped. The burnt, oxidized iron wool is now heavier. But hang on a second. How is that even possible? We burned it. Shouldn't it weigh less? Or maybe the same? Where did this extra weight, this extra mass, even come from? And here is the absolutely brilliant answer. That extra mass didn't just appear out of thin air. Well, actually, it kind of did. It was pulled directly from the air itself. Invisible oxygen atoms, which do have mass, latched onto the iron atoms during the reaction. They created a whole new, heavier substance, iron oxide. It's not magic, it's just awesome chemistry. So the big takeaway here is that oxidation is all about a substance gaining oxygen. But, in chemistry, for every action, there's often an opposite. The reverse of gaining oxygen is, well, losing oxygen. And that has a name too, reduction. Pretty simple, right? One gains, the other loses. Now, to describe these reactions without writing a whole novel every time, scientists use a universal language, a kind of special shorthand called a chemical equation. It lets them show exactly what's happening atom for atom. Let's start simple with a word equation for our rusty bike. On the left side, we have what we call the reactants, basically the ingredients for the reaction. Iron plus oxygen. The arrow just means react to form, and on the right side, we have our final dish, the product, iron oxide, which is just the fancy chemical name for rust. But we can be even more precise using a symbol equation. Instead of words, we use the symbols from the periodic table, Mg for magnesium and O2 for oxygen. And those little letters in the parentheses, they just tell you what state everything is in, S for solid and G for gas. It's like the super detailed version of the recipe. Now, some oxidation reactions, like an apple browning, are slow and gentle, but others are incredibly fast and energetic. So let's look at one of the most spectacular examples out there, burning a strip of magnesium metal.
This reaction is the perfect showcase for just how much energy can be released. When magnesium oxidizes, it doesn't just glow, it erupts in this blindingly bright white light. And it releases a ton of energy as heat. It is a truly powerful display of oxidation in overdrive.
But with that much power comes some serious risk. The light from burning magnesium is so intense that it can actually damage your eyesight if you stare right at it. Plus, the reaction gets incredibly hot and can cause some very nasty burns. So, how do scientists handle this safely in a lab? Well, it's all about smart precautions. They'll look at the reaction through a really dark filter, kind of like what's in a welding mask, to protect their eyes. And they always use long tongs to hold the magnesium strip, which keeps them a safe distance from all that intense heat. Okay, as we start to wrap this up, let's circle all the way back to our main idea about oxidation and leave you with one last interesting question to chew on. We've really established that oxidation is this fundamental process where a substance combines with oxygen. So, iron plus oxygen gives us iron oxide, or rust. It's a building process, creating new compounds by adding oxygen atoms.
So here's the final question. If oxidation is the process of creating rust by adding oxygen to iron, what kind of process would it take to reverse it? How could you take that flaky, brittle rust and turn it all the way back into strong, pure iron again? What would you have to do?